Hello, my lovelies. Welcome back. I hope you had a restful spring break. So now we are going to start shifting our focus and moving over to chapter 4. So we do have a test coming up next week. And the test is over the topics listed in the syllabus, but 4B is going to be one of those and 4C, but not 4D because the test is next week and we're doing 4D next week, so that's not cool. But the last two sections from chapter 7 will also be there. Okay, so 4B, we start talking about money with saving money and interest. Here we have the term principal. Now, sometimes people will spell it PLE at the end. Sometimes people will spell it PAL at the end. I think PAL is technically the correct one, but like honestly, everybody confuses the two because you say them the same. But the principal in financial formulas is the balance on which interest is paid. So the principal is very often your starting amount or your initial investment or the initial amount you borrowed. But it's the starting thing, the first thing. So principal. Simple interest is interest paid only on the original investment and not on any interest added at later dates. So simple interest, you just calculated on the investment. The next year you calculate it again on the investment, just like that. Compound interest, though, is interest paid both on the original investment and on all interest that has been added to the original investment. This is what your student loans do. So you have the initial amount you borrowed. Then they calculate the interest for that and add that to the total. Now they calculate the interest on the new total and add that to the total. So this is how it grows much faster than you realize. Home mortgages do the same thing. This is why paying a little more is good, because you're paying down that big number that you're going to take the percentage of. So the more you can get it down earlier, the less money there is to grow at the exponential rate. Okay. So let's check out simple versus compound interest. So suppose your principal investment is $1,000 and you plan to receive 5% interest gain every year and you invest for 5 years. Okay, we're gonna make a table. Insert table. Let's see, 6. Let's do like that. All right. Whoa, where'd everything go? Oh, seriously. Man, tables get buggy. Okay. So we have a principal, or the initial investment. So this is going to be like what's in the account at the start of every year. And then we have the simple interest we're going to calculate. So in this case, we're working with 5%, which we need to work with it as a decimal. So that is 0.05 or 0.05. So the principal investment is $1,000. 5% of 1,000 is $50. So we do 0.05 times 1,000. There's our $50. And now that is how much money I would have. So we call this A for the annuity, or sometimes it's called the future, but it's all confusing. But A is usually the letter we put on the other end. I always think of it as the actual amount in the bank account, in the account. There we go. So we're just going to add. So we'll have 1,000 plus that $50. All right, now we're going to do this 5 years. So the next year on simple interest, I still calculate it based on that initial investment. So it's going to be another $50. And in fact, every year it would just be $50. And then we would just add 50 each year. So then it'd be 1,100, and then 1,150, and then 1,200, and then 1,250. So not a lot. Now let's check out the insanity of compound. So let me just real quick. I'm going to copy that over there so we will be able to compare. But right now, so the first year is going to be the same. We still, all we had was 1,000. We calculate the interest on that. And now we have 1,050. Now we're starting the year with $1,050, and we are going to calculate 5% of that. We get 52.25, and now we are going to take the amount we had and add 52.5 to it. Now we have 1102.5. See, in Excel, this is a lot easier because you can set the formula 0.05 times, and you just say previous cell, and then the next one you would say this cell above plus this cell here goes here, and you can just copy formulas down, and it's way nicer. And then we add that 11.2.5 plus 55.125. And yes, I know we don't have a half a cent, but when it comes to interest, the student loan and the bank will carry these decimals forever because those decimals add up. All right, so now that's what we have in the account. Now we're going to do 5% times that amount. And then we are going to do that amount plus this one. Now we have this crazy amount. Yay for copy paste. And that is how much we have at the end, 1276.28. And then the 0.16 would just be kept by the bank, as it were. So we actually have about 26 more dollars than we do with the simple interest. Now imagine instead of 1,000, it's 10,000 or 100,000. These numbers get big faster, like 100,000 is now a small mortgage. So we have formulas to save us from trying to do this by hand, though. So I do not expect you to actually do this. This was just an example of here's what it looks like as you do it. There's a little more intricacy that the insurance or student loan companies will do, Your credit cards work closer to compound interest, but it's a slightly different compound interest. So here are the actual formulas. So simple interest is just the principal times the rate times t, the number of years. And that gives you the amount of interest. Then, let's see if I can, the end amount, actual amount in the account would be the principal plus the PRT. So we'll often like have those formulas paired together. Some questions will ask you, how much interest will there be? Other questions will ask you, how much will be in the account? So the account amount is the A thing. We have to add our interest to the principal. Now on compound interest, this is already set up to give us the actual amount. That's what the P times all of that is for. APR here is the annual percentage rate as a decimal. So APR is like the same acronym they're going to use in your credit cards. And on your credit cards, those happen monthly. So we're going to take the annual percentage rate and then we're going to divvy it up over the year. So it's annual here. We're only doing it once a year. But later, the annual rate is actually going to be different from what we actually calculate with each month. And then Y here is number of years. So here they had another note. The principal is often called the present value because that's what we start with. That's what's in the account at present. And then the accumulated balance, there's why it's A, is often called the future value because it is the amount that will be accumulated at some point in the future. And then the admonition, you make sure you use it as a decimal, not a percent. You will get crazy answers without doing the decimal conversion. All right, so I'm going to pause it and then start those in the next one.